Hi everyone, this is the Lesson 11 Extra Practice ECON315 Guided Study Group session. So today there's 3 problems. They're all kind of algebraic. They have a little bit of concepts in it, but should be a pretty quick session today, so let's get started. Number 1 is about efficiency wages and unemployment. So suppose the supply curve for labor in a competitive industry is given by LS equals minus 50 plus 15W, and the demand curve for labor is labor demand equals 130 minus 15W. So number 1 says, what is the equilibrium wage and employment, and what is the unemployment rate? So the first part, equilibrium wage and employment, we've done dozens of times by now, so I'm going to move through this pretty quickly. So as always, I'm going to write out the given information, which is LS equals negative 50 plus 15W, and then LD is 130 minus 15W. So of course, solving for equilibrium, we can just set supply and demand equal to each other. So negative 50 plus 15W equals 130 minus 15W. So then adding 15W to both sides, we get 30W on the left, and then adding 50 to both sides, we get 180 on the right, and then dividing by 30 on each side, we get W equals $6. So we know that the equilibrium wage in this case is $6, and then since we're in equilibrium, we can plug that back into either equation. And I'm going to use labor demand. So the equilibrium level of labor is equal to 130 minus 15 times 6. So labor equals 40. And then the last part asks about the unemployment rate. And as I've said before in previous problems, since we are in equilibrium, the unemployment rate is going to equal 0. And again, if you're thinking about this graphically, if we had demand and supply, we're in equilibrium when the two intersect. Unemployment is usually when we are at a wage that's above equilibrium, and it would be denoted by this difference here. That would be unemployment, or the amount of people unemployed. But again, this problem asks about the unemployment in equilibrium, and we know that since the market's in equilibrium, the unemployment rate is 0. So then number 2 says, suppose now that all firms pay an efficiency wage of $7 an hour, how many workers lose their jobs, and what is the increase in the size of the labor force? What is the increase in the labor force participation rate? So for part 2, the wage was $6, and now they're paying an efficiency wage of $7. How many people lose their jobs? So when we're looking at the amount of people who are hired in a firm, we're looking at labor demand. So what we need to do is plug the $7 into our labor demand equation to see how many people firms are demanding, and then compare that number to what we just found. So labor demand equals 130 minus 15 times 7. So this comes out to be labor demand equals 25. And then compared to the original 40, we can see that 15 people lose their jobs. And then it asked what was the increase in the size of the labor force. So when we're looking at the labor force, and I think I've mentioned this in a past problem also, when we're looking at the labor force, we're looking at labor supply because it's the total amount of people supplying their labor. Labor force is made up of the amount of people who are willing and able to work. So to find this, we have labor supply. We find it the same way we did in the last one, but now using labor supply instead of labor demand. So labor supply is negative 50 plus 15 times the wage of 7 now. So then this comes out to be a labor supply of 55. And then compared to our original labor level of 40, remember our equilibrium labor level is both labor demand and labor supply. So now we can compare these outcomes to both. We can compare both of these outcomes to 40, in these problems. So again, comparing 55 to 40, we can see that 55 minus 40 is 15. So we can see that the labor force grew by 15 workers. So from this efficiency wage, 15 workers lose their jobs, but then 15 workers join the labor force. And then it asked about the labor force participation rate. We know that the labor force participation rate is the number of the labor force over the amount of people in the population. So we already have the amount of people in the labor force, but we do not have the amount of people in the population. Therefore, we cannot solve for the labor force participation rate. And we just won't know the answer in this problem. We cannot calculate it. So then finally for part 3, it says, what is the new unemployment rate as a result of the efficiency wages? So this ties perfectly into what I said in number 1 because, as I said before, now I'm actually going to draw it out. We have wage, we have labor, demand, supply. So originally we were here at 40 and 6. And now this efficiency wage caused us to go above equilibrium, and then labor demand is 25 when labor supply is 55. So to find unemployment, like I said earlier, it's this difference between the amount of people supplying labor and the amount of people who are being hired, which should make sense in the back of your mind. So again, that's just going to be the difference between labor demand and labor supply because the amount of people who are willing to work but don't have a job is unemployed. So we can just calculate that as the amount of people supplying their labor minus the amount of people actually being hired. So we can see that 55 minus 25 equals 30. So 30 people are unemployed and is what this gap is up here. So then we know our unemployment rate equation is the rate equals the amount of people unemployed over the amount in the labor force. So we just solved for the amount of people unemployed, which is 30, and then we already said that the amount of people in the labor force is now 55. And I got each of these two numbers over here from before I compared them to what our original equilibrium was, just to backtrack a little bit. So then this fraction comes out to be 54.5%. And that is our answer for the unemployment rate. So again, just to recap this problem, I looked at, in this first column, we just found the equilibrium, wage and labor, and then from this efficiency wage change, I found the new excuse me, I found the new labor demand and labor supply, and then I compared that with the equilibrium to see the changes, and then I used the new labor demand and labor supply I found to figure out the amount of unemployed people and then the unemployment rate. So a pretty straightforward problem, just a lot of application and thinking things out. But I think it's very manageable. But that is all of number 1. So I'm now going to move on to number 2. So this says level of pay. Consider a firm where the optimal output is 36 units per day. If the firm pays its workers a wage of $50 per day, each worker produces an output of 4 units. If it pays its workers a wage of $100 per day, each worker produces an output of 9. What is the profit maximizing strategy for producing 36 units of output? So thinking about this problem, there's not a lot of math to it, but thinking about it, either way, whether it goes with paying workers $50 or $100, they're still going to be producing 36 units a day. So that means that either way, the total revenue will be the same. So since in either situation, the total revenue is the same, the firm's going to choose the option with a greater marginal product of labor per worker. So in this case, we see that the second option, let me go back. So we can see that the second option of paying its workers a wage of $100 per day, where they produce an output of 9, producing an output of 9 is the marginal product of labor. So again, since the revenue is going to be the same either way, they're going to choose the option with the greater marginal product of labor per worker, which is the second option. So then in determining how many workers to hire, if the output is 36 units per day and then each worker can produce 9 units, it's just simple division, seeing that 36 units, 9 units per worker. So what happens is the units cancel out and we get 4 workers. And that is all that was needed for this part of the problem. Just recognizing that in a profit maximizing strategy, when the revenue is the same, they're going to choose the option where they get a greater marginal product of labor, MPL, per worker, which is the second option. So in the end, the firm should pay a wage of $100 and hire 4 workers. So then part 2, assuming the going wage rate for comparable workers is $50, can the firm be described as paying an efficiency wage? So this problem was more conceptual than I thought, but not too hard. So can the firm be described as paying an efficiency wage? So this move would be consistent with an efficiency wage strategy, but whether the $100 could actually be considered the efficiency wage depends on whether further increases in the wage continue to increase profits. Because if increases in the wage still increase profits, then the $100 that's far above the going wage rate would not be an efficiency wage. Because if you go back to your notes, an efficiency wage is a higher than average wage paid to attract the best workers and prevent shirking. So if this wage is actually helping with profits, then it's not an efficiency wage. But if it's not helping with profits, but only attracting the best people, then it is an efficiency wage. So that one was just a matter of looking back at your notes and recognizing whether it's an efficiency wage or not. But in this problem, it's hard to say because it depends on whether it's influencing their profits or not. But that was all of number 2, pretty quick. So then moving on to the last one, consider a firm where the marginal product of the typical worker varies over time according to the schedule below, where year 0 represents the current year. In order to motivate its workers to exert their best efforts, suppose this firm plans to sequence the pay in such a way that workers receive less than their marginal product early in their career and then more than their marginal product toward the end of their career. So if the firm has decided to pay workers the real wage value shown in the table above for years 0, 1, 2, and 3, what is the minimum the firm could pay its workers in period 4 and still have the plan be acceptable to the workers? Assume the real interest rate is 6%. So looking at this problem, it might be hard to see why they give us a real interest rate, but this actually has to go back to the idea of net present value. So you can kind of see that in the wording when it says still have the plan be acceptable to workers. So another way of thinking of that in net present value terms is taking what wage do they need to be paid in period 4 for this job to be, I guess, a good investment. Not the best way to say it, but if we're thinking in net present value terms, that's a okay way to think of it in my mind. So I think a better way to show this is to graph it, which sounds a little weird at first, but hopefully you'll see what I mean. So I can draw a really quick graph here. So the y-axis will be like the marginal revenue product or the wage. And then the x-axis will be the year. So this is year 0, and then we have 1, 2, 3, 4. So I'm going to make 2 different lines. So the first one is going to be wage. So if you look back at your table, if you have it in front of you, in year 0, the real wage was $3. In year 1, it was 8. Year 2, it was 12. Year 3, it was 15. And then year 4 is what we're trying to figure out. But I'll still draw it on there. That doesn't fully line up, but hopefully you see what I mean. So then the second line is going to be the marginal product. So the marginal product for year 0 was 6. Year 1 was 10. Two was 13. 3 was 15 again. And then 4 was 16. So again, my lines don't fully match up, but what I'm going to show you is these. You can see from 0 to 3, there's like this really thin triangle shape, and it's the difference between the real wage and the marginal product for this time period. So I'm just going to shade it in the screen color. And then over here, this blue one is what we're trying to find. But pretending we know what it is, I'm going to shade in this other green triangle over here. So now going back to the equation, to the word problem, they were asking what the wage would be to have the plan be acceptable to the workers. So this, when they mean by acceptable, we can look at this graph and see that acceptable would mean having these two triangles equal each other. The area of these two triangles equal each other. Because on the left, we see that they're getting paid less than what they're worth. But then on the right, they're getting paid more than what they're worth. So as long as they're getting paid in the end, overall, in their lifetime, as long as they're getting paid equal or more than what they're worth, it'll be acceptable. So ideally, we would want, so this area is the underpay section, or I'm going to call it the underpay section. Then this area I'm going to call overpay. So ideally, we would want underpay to be less than or equal to overpay. So hopefully now what you realize that what we need to find is this value for the wage in period 4 to make these two areas equal to each other. And now you're probably asking, how do you do that? Well, this is where the things we've learned about net present value come in. So what I can do is I can set up the underpay side as with the idea of the present value equations of like present value equals future value over 1 plus r to the t. And so the summation of those for the underpay years, and set that equal to the summation of the present value terms for the overpayment years. So I think once I write it out, it'll make a little more sense. So I'll start with period 0. So period 0, the equation is going to be, so remember in net present value, we talked about incremental earnings or difference of earnings. That's the same exact thing we're going to do here because that's what this triangle highlights. This triangle highlights the difference between what they're getting paid versus what they're getting worth. So this difference is what we're going to use in the future value portion of our present value equation. So the first period would be, or period 0 would be 3 because it's 6 minus 3 over 1 plus 0.06 because that's the discount rate they gave us, or the real interest rate, excuse me. The real interest rate is 6%, so that's what we're going to put in our R value, raised to the 0 power. But we know that anything raised to the 0 power goes to 1, so this just remains at 3. We can tack that onto 2 because it is 10 minus 8 over 1.06 to the first period, to the first power because it's period 1. And then lastly, the difference for period 2 is 1 because it's 13 and 12, and then 1.06 to the 2. For period 3, since they equal each other, we don't need to write down anything for that. So this is the left side of this equation, the underpayment part. And then for the overpayment part, we only need to do the 4th period. So the difference of earnings would be, let's denote this new wage as W. So W minus 16, because 16 is what they're worth, the marginal product, over 1.06 to the 4th, since we're in period 4. And then after setting this up, all we have to do is solve for W to find the answer. So hopefully now that I've written out the equation, it makes a little more sense to you of how this problem is laid out. I think graphing it also helps to see it also, like realizing that the two triangles, the areas of the two triangles need to be equal. But I understand that it's a confusing problem. It was hard for me when I first got it. So I truly believe that you can understand it also. But anyway, solving for this problem. So simplifying this all down. Remember, this is only 3 now. So then this entire left side, I got out to be 5.78. And then I'm still going to leave the right side untouched. And then we can isolate W by multiplying each side by the denominator on the right, so 1.06 raised to the 4th. And then we can tack on 16 equal W. So I moved this over there, and then I moved this over there. And then finally simplifying this all down, we get a wage of $23.29. So looking at this answer compared to the rest of the table, it might seem a bit weird because it's not a solid number. It's not it's not a solid or simple answer, but that is how to solve the problem. So don't not believe it when you first see it. Just check over your math, see that everything's right. But this is the way to do the problem. So that is all we need to do for this one, actually. It was just, I think the hardest part was understanding what they were asking and then setting up the equation, because we had to pull a couple things together. But I fully believe that you are all capable of understanding it. So then finally, after that, we have the last part of the problem, which says, why is such a pay scheme more likely to be found in firms using an internal labor market strategy? So a necessary condition for such a deferred payment scheme is a long-term relationship between workers and the firm. Remember, these workers want the overpayment to be greater than or equal than the underpayment. So for that to be possible, they have to be there a while. So internal labor market strategies promote long-term attachment by filling upper-level positions with workers from within the firm. So filling upper-level positions with workers from within the firm is what an internal labor market strategy is. So thinking about what requires this idea of eventually in the end having the overpayment equal to or greater than the underpayment, you need people to be there for a long time, so it's easier to just hire people from within. But that is all for today, so hopefully you're able to follow along. Any questions, feel free to email me, but best of luck in your studying, and I will see you next week.